Like where did we end in our last class? From where are we supposed to discuss? Numbers. From the starting? From the starting of numbers, or have you seen any concepts? So numbers, we can say this is the most important topic present here, or one of the most important topics. In numbers also we have a lot of concepts to discuss. After geometry, this is the topic where we are going to discuss. In terms of number of concepts, after geometry, this is the concept. This is the topic where we are going to discuss maximum number of ideas. So first, let us start with basics, and after that, we will look at remaining concepts involved through formula sheet. For example, let's say we need to know factors of 10. Factors means numbers which will exactly divide 10. We say 1, 2, 5, 10 are factors of 10. Similarly, minus 1, minus 2, minus 5, and minus 10 are also factors of 10. So when we talk about factors, you have to consider both positive as well as negative integers. Factors can be positive as well as negative. Not only factors, multiples. So if you are considering only positive numbers, remember this idea. When we talk about factors or multiples, they can be positive as well as negative. Because if you look at the definition of factors, if R, S, T belongs to integers, if R, S, T belongs to integers, and R into S gives us T, then R and S are said to be factors of T, or T is a multiple of R and S. If R, S, T belongs to integers, and R into S gives us T, then we say R and S are factors of T. So for example, if you consider this integers means, if you look at the list of integers, minus 3, minus 2, minus 1, 0, 1, 2, like that, integers can be positive as well as negative. So 2 is an integer, into 5 is an integer, gives us 10. So we say 2 and 5 are factors of 10. Similarly, minus 2 is also an integer, into minus 5 is also an integer, gives us 10. So we say minus 2 and minus 5 are also factors of 10. So when we talk about factors, they can be positive as well as negative. Now this is one way to put the definition of factors. R into S gives us T. Similarly, you can write R is equal to T by S. R into S is equal to T is nothing but R is equal to T by S. Then also you can say S is a factor of T. So while solving problems, we'll be looking at a simple rearrangement of this formula. If y comma x belongs to integers, if y comma x belongs to integers, and y when divided by give x, if it gives an integer, if y comma x belongs to integers, and y by x gives us an integer, then y is said to be divisible by x, or y is multiple of x, or x is factor of y. If y comma x belongs to integers and y by x gives us an integer, then we say y is divisible by x, or y is multiple of x, or x is factor of y. So while solving problems, when you come across any of these three terminologies, any of the terminologies in the form of y is divisible by x, or y is multiple of x, or x is factor of y, then immediately take y by x must give us an integer. So in all the questions where we see this terminology, the first step is say y by x gives us an integer form. And what are our next steps will depend on what he has given, other information, what he has given, and what we need to find out about. So if y comma x belongs to integers and y by x gives us an integer, then we say y is divisible by x, or y is multiple of x, or x is factor of y. So like we did in geometry, going through formula sheet, we will look at different concepts involved. To open the formula sheet on numbers, Can anyone tell me the page number? It would be around 158 or 159, something there. 156. Or drive link page number QS3 or PDF page 263. Try these concepts from 24 to 34. Not QB63. I am asking about formula sheet, not the theory part. It will be QH pages. QS3, page number QS3. There are QH2, QS2 online page number 262. Try these questions from 24 to 34. We will discuss them in few minutes.
Exponent पछि लेख्दा थियो कहाँ छ exponent? नम्बर 63 हैन 63 र 87 के पछि छ है एक्सपोनेन्ट ए जियोमेट्री त्यहाँ रहेछ नि त इनइक्वालिटी एन्ड मोडुलस पछि रहेछ 130 तिर होला 26 आउनु एक्सपोनेन्ट पछि छ भनेपछि के हो भेन्डा जानुहोस् जियोमेट्री पछि एक्सपोनेन्ट एक्सपोनेन्ट पछि एक्सपोनेन्ट यो होइन कि क्युबी लेखेको छ हेर्दा क्युएच को सोधिरहेको थियो क्युबी हो क्युबी हो क्युएच जस्तो यसमा छैन ये चाहिँ कुन देखेको 24 देखि 34 हेत तेरि कति लामो 24 देखि 34 हे खै यत्रो लामो टाइम गइसक्यो यही होला कि सर 24 देखि 34 देखेको QH2 156 र 262 देखेको यसको 262 हो यसमा चाहिँ यो 11 मेरो कति अर्को GRE1 कति मान्छे GRE1 मा कहाँ अरे त्यो नम्बर च्याप्टर 8 थियो सक्यो भएन गाह्रो त्यो नै गाह्रो छ यसको साइजहरू चाहिँ घटाउनु मिलेन कि होइन मिलाइदिइहाल्छ यसमा पनि छ होला कि नम्बर्स त्यो देखि QH2 भनेको होइन QH2 QH29 हो कि
Concentrate here now. Let's discuss these concepts.
सकिसक्यो
Divisors of 10. Divisors of 10 are nothing but factors of 10. Numbers which will exactly divide 10. 1, 2, 5, 10 are factors of 10. Similarly, minus 1, minus 2, minus 5, and minus 10 are also factors of 10, or we can also say divisors of 10. Just now we have seen this. Next, when you talk about multiples of 10, there are infinite multiples of 10. Any number of the form 10 into some integer, we say it is a multiple of 10. So like minus 20, minus 10, 0, 10, 20, like that. We have infinite multiples of 10. If y by x gives us an integer, we say y is a multiple of x. Similarly, if y by 10 gives us an integer, we say y is a multiple of 10. So y will be of the form 10 into some integer. Any number of the form 10 into some integer, we say it is a multiple of 10. So there are infinite multiples of 10. Next, what are the prime factors of 60? Now, prime number. A number is said to be prime if it has only two positive factors. A number is said to be prime if it has only two positive factors, one and the number itself. So one way is you have to find out what are factors of 60 and then observe what are prime numbers in it. Or else instead of that, prime factorize this 60. 60 can be written as 4 into 15, means 2 square into 15 means 3 into 5. Prime factorize this and take the prime numbers involved, 2, 3 and 5. So whenever you have to prime factorize a number, instead of completely dividing it, like writing everything down in detail, 230s, 215s, 3 5s, like that, we can go through this approach. But instead of that, try to reason, like, how can I split this number as product of which numbers? Like that, by simplifying, we can directly prime factorize this. 4 into 15, 15 means 3 into 5, 4 means 2 square. So 2 square into 3 into 5. And the prime numbers involved here are 2, 3 and 5. So 2, 3, 5 are prime factors of 60. And one more important point, 1 is not a prime number. 1 is not a prime number. Least possible prime number is 2. Prime numbers will start from 2. Because a number is said to be prime if it has two positive factors. But how many positive factors does one have? Only one itself. So 1 is not a prime number. Next one, sum of positive factors of a prime number is. For example, let's say there is a number n which is prime. If I say n is prime, if it has only two positive factors, 1 and the number itself, 1 comma n. What is their sum? 1 plus n. So sum of positive factors of a prime number is 1 more than the prime number. Sum of positive factors of a prime number is 1 more than the prime number, 1 plus n. Because it has only two positive factors, 1 comma n, their sum is 1 plus n, 1 more than this n, where n is a prime number. Next one, 0, odd or even. 0 is an even integer. So these are all some basic ideas, I hope which all of you know, but knowledge of which is very essential here. That's why we are starting from basic ideas. 0 is an even number. So when you are considering list of even numbers, you have to include 0 in that list. Because any number which is divisible by 2, we say it is even. 0 is an integer. When divided by 2 gives us 0, which is an integer. So we say 0 is divisible by 2. Any number which is divisible by 2 will be even. If a y by x gives us an integer, we say y is divisible by x. So 0 by 2 is giving us an integer. So 0 is divisible by 2. So it is even number. Whereas under positive and negative, 0 is neither positive nor negative. 0 is neither positive nor negative. When we say non-positive numbers, you have to consider 0 in that list. When I say non-negative numbers, in that list also you have to consider 0. 0 is neither positive nor negative. Next, a into b is equal to c. If a and b are different prime numbers, how many positive factors does c have? He said a and b are different prime numbers, then a into b will have four positive factors. 1, a, b, a into b. Because a is a prime number, it has only two positive factors, 1 comma a. B is a prime number, it also has two positive factors, 1 comma b. in product combination of this 1b a ab, because a into b gives us ab, 1 into ab gives us ab, but there is no other way to split this as product of some other integers because they are prime numbers. So let's see an important idea here. Consider a, which is a prime number. Consider a number a which is prime. If a is a prime number, a square will have three positive factors. 1 a square. A into a gives us a square, 1 into a square gives us a square. Similarly, if a is a prime number, a cube will have four positive factors. A cube will have four positive factors. 1 a square, a cube. Like that, if a is a prime number, a power n will have n plus 1 positive factors. If a is a prime number, a power n will have n plus 1 positive factors. Using this concept, we will find out how many positive factors does a given number have. For example, if you want to find out how many positive factors then 10 has, you simply say 1, 2, 5, 10, and you will count them 4. But when we have to deal with some higher numbers like 2250, 2500, like that, counting all the finding all the factors and counting them would be a lengthy approach. Instead of that, we will use this idea that if a is a prime number, a power n will have n plus 1 positive factors. For example, let's say you need to know how many positive factors does 200 have. How many positive factors does 200 have? First step, prime factorize this. Express it as product of powers of prime numbers. 200 can be written as 8 into 25. 8 means 2 cube, 25 means 5 square. 2 cube into 5 square. Or else you have to start with the prime number, let's say 2, keep factorizing it, 200s, 250s, 225s, 5 5s. Now we will multiply all this 2 into 2 into 2 into 5 into 5, which is nothing but 2 cube into 5 square. Now we use the idea that if a is a prime number, a power n will have n plus 1 positive factors. If a is a prime number, a power n will have n plus 1 positive factors. 2 is a prime number, so 2 cube will have 3 plus 1 positive factors into 5 is also a prime number, so 5 square will have 2 plus 1 positive factors. Total 4 into 3, which said 200 has 12 positive factors. So first to prime factorize the number, express it as product of powers of prime numbers. Then to find the number of positive factors, use this idea. If a is a prime number, a power n will have n plus 1 positive factors. So 2 cube will have 3 plus 1 into 5 square will have 2 plus 1, 4 into 3, total 12 positive factors. Next one, product of two positive integers is equal to. So here there are two important terms which we have to know. One is greatest common factor or highest common factor. The common factor which is greatest in value, or the common factor which is highest in value. Greatest common factor or highest common factor. Let's say we need to find out what is greatest common factor of 24, 32, 48. We need to know what is greatest common factor or highest common factor. Let's say 24, 32, 48. Now 24 can be written as 8 threes, 2 cube into 3. 32 can be written as 2 power 5. 48 can be written as 16 into 3. First prime factorize these numbers. Then to find this greatest common factor, take that value which is common in each and every term. Take the value which is common in each and every term. The common value present in each and every term is 2 cube. So we say greatest common factor of 24, 32, and 48 is 2 cube 8. Now there might be 3 in 24 and 48, but there is no 3 in 32. There might be 4 twos and 5 twos, 4 twos in 48 and 5 twos in 32, but there are only 3 twos in 24. So the common part present in each and every term is 2 cube. This is on how to find out greatest common factor or highest common factor of given numbers. Then one more important term, least common multiple. Least common multiple. Least common multiple means the common multiple of given numbers which is least in value. Common multiple of given numbers which is least in value. So let's say we need to find out what is least common multiple of 24, 32, 48. If you want to go through the divisional approach, you can use the divisional approach as well. Or else, like we did earlier, first prime factorize these numbers. 24 can be written as 8 into 3. 32 can be written as 2 power 5. 48 can be written as 16 into 3. 8, 24 is 8 threes. 32, 2 power 5. 48 is 2 power 4 into 3. Then to find this least common multiple, take the prime number involved and raise it to the highest power present. 2 is a prime number involved, raise it to the highest power present 5. Into 3 is another prime number involved, highest power of 3 is 1. 2 power 5 into 3, 32 into 3, which is 96. So least common multiple of 24, 32, and 48 is 96. First prime factorize these numbers, then take the prime number involved and raise it to the highest power present. So least common multiple, here it is 96. So product of any two positive integers, product of any two positive integers will be equal to their greatest common factor into least common multiple. Product of any two positive integers will be equal to their greatest common factor into least common multiple. GCF into LCM. So let's say one of the number is given, their greatest common factor and least common multiple is given. By using this idea, you can find out what is the other number. And for any two consecutive integers, highest common factor is 1. For any two consecutive integers, highest common factor is 1. Take any two consecutive integers and observe. 4 and 5, highest common factor 1, or 6, 7, or 21, 22, or minus 4, minus 5, or minus 10, minus 11. For all those consecutive integers, highest common factor is 1. Next one. If a number is divisible by x and divisible by y, then the number must be divisible by LCM of x and y. If a number is divisible by x and divisible by y, if a number is divisible by x and divisible by y, it must be divisible by LCM of x and y. If a number is divisible by x and divisible by y, it must be divisible by LCM of x and y. No need to be product. For example, take 12. 12 is divisible by 4. 12 is divisible by 6. Is it divisible by product of 4 and 6? So if a number is divisible by x and divisible by y, it must be divisible by LCM of x and y. For example, let's say there is a number n. He said n is divisible by 3. I said earlier, y is divisible by x, y is multiple of x, or x is factor of y. Whenever you come across these terminologies, first take it as y by x gives us an integer. So n is divisible by 3 means n when divided by 3, resultant value must be equal to integer. And let's say n is also divisible by 5. Then you say n when divided by 5 must give us an integer. Let's say I1, I2. Now here when we deal these kind of questions, if we are taking these two equations, then we have to deal with each equation individually and then select those values of n which satisfies both. Instead of that, use this idea. If a number is divisible by x and divisible by y, it must be divisible by LCM of x and y. So it must be divisible by LCM of 3 and 5, which is 50. So we just take it as n by 15 gives us an integer, which makes us deal with only one equation. So if I say n is divisible by 15, that means it will be divisible by 3, it will be divisible by 5. Those conditions will automatically be satisfied. So if a number is divisible by x and divisible by y, it must be divisible by LCM of x and y. Next one. For the decimal 253.846, which digit is in the hundreds place? 253.846. Which digit is in the hundreds place? Now, left side of decimal, we know tens, units place, tens place, hundreds place, thousands place, like that. Right side of decimal, we add THS at the end. It starts with tens. Tens place digit, 8 is in tens place. Then next, hundreds, thousands, 10,000s, like that. We add THS at the end. There is no units place. It will start from tens, then hundreds. Which digit is in hundreds place? 4. So hundreds place digit is 4. Now, as we are talking about these decimals, let us also look at the concept of rounding off. For example, let's say there is a decimal 853.84478, and he is asking us to round it off to hundredths digit. Let's say you need to round it off to hundredths digit. So whenever you are rounding off to a particular place, only observe what is the digit next right to it. Just observe what is the digit next right to it. Only one that digit. We are rounding off to hundredths digit. So observe what is in thousands place. The digit next right to it. If this digit is less than 5, we write it as it is. Like in this case, it is 4. It is less than 5. So we write as it is 253.84. If this digit, if this digit is greater than or equal to 5, if this digit is greater than or equal to 5, means 5 or more than 5, we add 1 to the place which we are rounding off. We add 1 to the place which we are rounding off. 84 plus 1, we say 85. And also it's not like here 8, so I will add 1, here 7, so I will add 1, now 5, I will add 1. That's wrong. That's conceptually wrong. We cannot go like that. So whatever digits are right side of this word, it doesn't matter for us. Only observe the digit which is next right to it. If this digit is less than 5, write it as it is. If it is 5 or more than 5, add 1 to the place which you are rounding off. This is how to round off these decimals. Next one, m is a two-digit number and n is formed by interchanging the digits of m. Then sum of m and n. If m is a two-digit number and n is formed by interchanging the digits of m, sum of m and n will be a multiple of 11, and the difference of m and n will be a multiple of 9. If m is a two-digit number and n is formed by interchanging the digits of m, sum of m and n is a multiple of 11, whereas difference of m and n is a multiple of 9. For example, let's say m is 32. N is formed by interchanging the digits of m, 23. Then what is sum of m and n here? Sum of m and n is 32 plus 23, 55. Or difference of m and n. Difference of m and n is 32 minus 23, which is 9. So sum is a multiple of 11 and difference is a multiple of 9. And to generalize this, for example, if you take 32, we can write it as 3 into 10 plus 2. 3 into 10 plus 2 is nothing but 32 only. Any number you can expand like thousands place digit into thousand, hundreds place digit into hundred, tens place digit into 10, units place digit into one, like that. Here we are talking about a two-digit number. We have units place and tens place. So tens place a digit into 10, 3 into 10 plus units place digit into 1, 2 into 1, 3 into 10 plus 2 into 1, which is a 32. Similarly, 23 can be written as tens place digit 2 into 10 plus units place digit 3 into 1, 3. Like that. For example, let's say M is AB, where A denotes tens place digit and B denotes units place digit. N is formed by interchanging the digits of M. It will become BA. Now, sum of M and N. Before finding that, let us expand this number AB. Tens place digit A into 10, 10A, plus units place digit B into 1B. Similarly, BA. Tens place digit 10 into B, 10B, plus units place digit A into 1A. Then sum of M and N. Sum of M and N is 10A plus A, 11A, 10B plus B, 11B, 11 of A plus B. Then difference of M and N. 10A minus A, 9A, B minus 10B minus 9B, 9 of A minus B. So sum of M and N is a multiple of 11 and difference of M and N is a multiple of 9. Because A plus B means 11 into some integer. A plus B is some integer. So 11 into some integer is a multiple of 11. A minus B is some integer. 9 into some integer is a multiple of 9. So you will come across some concepts in number systems where if you just remember those concepts, in some model problems, all you have to do is just to look at the options and directly select the answer. But in the absence of those concepts, it would be very difficult or lengthy, or some models we cannot answer at all. So we said if sum of m, which of m is a two-digit number and n is formed by interchanging the digits of m, which of the following could be sum of m and n? Then you will just look at the options and select multiples of 11. And also, for example, if 220 is in the options, 220 is a multiple of 11, but we cannot select it because you should also be aware of this range. We are talking about two-digit numbers. Largest possible two-digit positive integer is 99. Interchange digits 99. 99 plus 99, 198. 99 plus 99, 198. So sum of two-digit positive integers cannot cross 198. So you should select multiples of 11, but which are less than or equal to 198. 198 is the maximum we can have. Next one. Product of two consecutive integers is always divisible by. Product of two consecutive integers. Let's say n is one integer. Consecutive integer, you can take n minus 1 or n plus 1. Anything. Let's say I'm taking n plus 1. Product of two consecutive integers. N into n plus 1. What about here? Product of two consecutive integers will always be divisible by which number? Product of two consecutive integers will always be divisible by which number? The one will definitely divide. One will divide any integer. 2. It will be 2. Because one will definitely divide. One will divide any number. We are looking at some other higher number 2. Because if you take numbers will be like even, odd, even, odd, even, odd, even, odd, something like this. If n is even, next number n plus 1 will be odd. If n is odd, next number n plus 1 will be even. So one of them will definitely be even, So it will be like even into odd. Even into odd is even. Product of two consecutive integers will be even, and any even number will be divisible by 2. So product of two consecutive integers will always be divisible by 2. What about product of three consecutive integers? N into n plus 1 into, let's say, n plus 2. Increasing sequence. I'm taking increasing sequence. Product of three consecutive integers will always be divisible by which number? Yeah, 2 will definitely divide, because two consecutive integers are divisible by 2. Three consecutive integers will also be divisible by 2. Some other higher number which will cover all the possibilities, or which will cover all the numbers that will divide this. It will be 6. Product of three consecutive even integers will be divisible by 6. So numbers, for example, let's say I'm taking positive numbers like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, something like this. For every three numbers, for every three consecutive numbers, you will have a multiple of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Try to take any three consecutive integers from this list. One will definitely be one will definitely be a multiple of 3. So sum of three consecutive integers will always be divisible by 6, because it is divisible by 2 and divisible by 3, so we say divisible by 6. So whenever you have to answer this kind of questions, try to reason how can we express this numerator as. So not numerator, how can we express this product as? For example, if I write it as 5 into some integer, you say multiple of 5. If I write it as 6 into some integer, we say it is a multiple of 6. Like that. Try to reason how can we express this product as which number into some integer, multiple of which number. Now one of them, whether you select even odd even or odd even odd, one of them will definitely be even. Any number, any even number can be written as 2 into some integer. And this, one of them will definitely be a multiple of 3. Any multiple of 3 can be written as 3 into some integer. 2 into 3, 6. Product of two integers, some other integer. So we say product of three consecutive integers will be a multiple of 6. Whereas product of two consecutive even integers, an even number, we will express it as 2 into some integer. This is how you express an even number. 2 into some integer, we say it is even. So let's say 2n is an even integer, and next one 2n plus 2. This product will always be divisible by which number? So try to evaluate this product. How can I write this product as which number into some integer? Like here, we write it as 6 into some integer, we say it is divisible by 6 or a multiple of 6. Yeah, 4 will divide any other higher number which will cover all the possibilities. 8. It will be 8. Product of two consecutive even integers will always be divisible by 8. So when I say divisible by 8, divisible by 4, divisible by 2, all this will be covered. So let us evaluate this product. First, you can take 2 common. Take 2 common. Now 2 into 2, 4 into n plus 1. Now n into n plus 1 means what? What is n here? Some integer. N into n plus 1 means product of two consecutive integers, which is a multiple of 2. 4 into some multiple of 2. It will be a multiple of 8. So product of two consecutive even integers will always be divisible by 40, divisible by 8. What about product of three consecutive even integers? 2n, next one let's say 2n plus 2, and next one 2n plus 4. You keep adding 2, you will get the next even integer. Product of three consecutive even integers will always be divisible by which number? Three consecutive even integers. Product of three consecutive even integers will always be divisible by which number? 48. So same kind of evaluation, just all we need to do is first take 2 common and see how this product is coming out to be. Try to reason how can we write this product as which number into some integer, which number will always be present in this product. So first we can take 2 common, 2 into n into 2 into n plus 1 into 2 into n plus 2, which is already 2 into 2, 4 into 2, 8 is already present. 8 into n into n plus 1 into n plus 2. This is product of 3 consecutive integers, which is already a multiple of 6. 8 into some multiple of 6, it will be a multiple of 48. And any multiple of 48, we say it is divisible by 48. Product of 2 consecutive integers is divisible by 2. Product of 3 consecutive integers is divisible by 6. Product of 2 consecutive even integers is divisible by 8. Product of 3 consecutive even integers is divisible by 48. And also in the representation which I used here, if you substitute n as 1, we will get those answers. Because whatever the starting numbers follow, next it would be like the multiples of these numbers keeps on continuing. So what these initial numbers follow, other numbers will follow the same trend. So if you substitute n as 1 also, we will get these values. But in this representation is also important. For example, I said I took n and n plus 1 as consecutive integers. Instead of that, if you are taking n and n minus 1, then you cannot put n there. In this representation which I took, if you substitute n as 1, then also it will give us the same answers. But at the same time, you must know the reasoning, like how we are getting it, how we can say it is divisible by a particular number. So these are some concepts present in this number systems. If there's any doubt, let me. So before looking at remaining ideas, let us solve some problems. And after solving few problems, we will look at remaining ideas. I think page 184 or else 1 or 2 pages here and there. Try these first 6 questions. First 6 questions present in class exercise of numbers. Drive link page number QS29 or online page number 218.
Nói đồ ăn rồi. Kìa kìa. Kìa nó này. Of course. छैन यहाँको भन्दा त हाम्रो घर त ठुलो मिठो लाग्छ यहाँ यस्तो जे पछि कुरा हाल्छ नि उता हाल्दैन नि उता सिधै चाउचाउ नै हाल्छ नि त गएर हामी पोजिटिभ इन्टिजर र फ्याक्टर्स अफ 100 100 भनेको कति हो 20 इन्टु 5 होइन त्यो भनेको 4 इन्टु 5 भनेको 2 स्क्वायर इन्टु 5 स्क्वायर भनेको कति हुन्छ पोजिटिभ फ्याक्टर भनेपछि 2 प्लस 3 3 2 प्लस 3 3 3 इन्टु 3 9 वटा आन्सर 2 integer greater than 0 quantity number of prime factors of 2n plus 2 भनेको के हो 2n plus 1 4n n plus 1 भनेको 4 टाइम्स n र n plus 1 को फ्याक्टरमा कति हुन्छ 2 हुन्छ कमा a to एन्सर ए यो त ए हो नि त क्वान्टिटी b भनेको के हुन्छ नम्बर अफ प्राइम फ्याक्टर्स अफ n n plus 1 भनेको 2 हुन्छ भनेको a इज ग्रेटर भनेको अप्सन ए छैन 2a plus b पनि इभन हो a by b पनि इभन हो a र b दुईटै इन्टिजर हो which of the following must be true के भन्दा a is even a divided by b इभन हो हैन यसले यसले हुन्छ so a इभन हो रोटी बनाइहालौँ है खाना बनाइहालौँ so 2a ultimately इभन हो so b मा डिपेन्ड हुन्छ के भागिन हानि ए भात भन्दा रोटी खानु पर्छ भात b इभन हो भात रोटी जे खान त एउटै त हो नि ए बाई बी भनेको 2 टाइम्स रोटी डाइस हुन स्लो पिसन त एकछिन इनर्जी आउँछ ए भनेको 2x हो 2bx हो so 2bx सरबडा खुर्सानी टोकेर खाएर त्यसले त पिरो हैन पिरो so this is always zero पढ्न थालेछ पिरो अलि बढी खानु लाइक क्लास चल्छ आमा हामी बोल्छ हैन प्र्याक्टिस हुन्छ के रे लाइक क्लास ल म बोलिरहेको तर त्यस्तो इफेक्ट हुँदैन कहाँ लिनुहुन्छ नि के पढ्नु पर्छ के पढाइयो नम्बर्स नम्बर्स क्वेशन गर्नु देखेको भाषामा कस के होला त्यसको लजिक ए बी इभन छ हजुरले जान्नु भएको है खै कुन हो मलाई मनमा कता कता त लाग्यो मलाई लागिरहेको थियो कि कसरी लाग्यो खै ल्याउन यतिकै हाँसिरहेको ए त्यो भयो हैन यहाँ हैन यो बाटोमा किन जान्नु भयो जस्तो लागिरहेको ठिकै छ सिनेमल कस्तो पूछे यार 2a plus b इभन हो a by b पनि इभन हो a र b दुइटै इन्टिजर हो कुन ट्रु हुन पर्यो a डिभाइड बाई b इभन हो भने टाइम समथिङ हो भने हो भनेको a त अल्टिमेटली इभन a भनेको इभन हुनै पर्छ यसको चोइसै छैन हो सो यदि a इभन हो भने इभन प्लस अर त कहिले इभन हुन सो b पनि इभन हुनै पर्छ त्यही होला आन्सर ए होइन ए a बाई b भनेको इभन होइन हो भने त a भनेको 2 टाइम्स b टाइम्स समथिङ हुन्छ नि त सो a भनेको इभन हुनै पर्यो होइन यदि a इभन हो भने इभन प्लस अड कहिले नै इभन हुँदैन नि त होइन सो b पनि इभनै हुनु पर्यो सो a र b दुइटै इभन हो भने हो a प्लस b इभन हुन्छ कि भन्नु अफकोर्स हुन्छ त्यो पनि इभनै हुन्छ a माइनस b इभन हुन्छ कि भन्नु नहुन सक्छ नहुन पनि सक्छ a माइनस b किनभने 4 र 2 भयो भने त हो 4 र 2 भयो भने a माइनस b भनेको 4 माइनस 2 इभन हुन्छ 0 र 2 भयो भने के हुन्छ त a by b a दुइटै a माइनस b नै हुन्छ
Concentrate here now. Let's discuss these questions. How many positive integers are factors of 100? So
9
while discussing the concepts in formula sheet, we have seen this model. There I took 200. Here is asking for 100. So whenever you have to find the positive factors of a number, yeah, it will be 9. First, prime factorize this number. Instead of finding all the factors like
सोधे
1,
आके
2,
भर्खरै
4, 5, 10,
गर्दैन त टाइम
20,
रेडी हो
25,
गर्दा
50, and 100, like I'm counting them. First, prime factorize this. 100 can be
खादिन
written as
खाउँ त
4 into 25. 4 means 2
तपाईँ मलाई
square,
खाएर
25
आजकल
means
खाना
5
खाइन
square.
खाना
Then to
नखाएको हुन्छ
find the
आज
number of positive factors, use the idea that if a is a prime number, a power n will have n plus 1 positive factors. If a is a prime number, a power n will have n plus 1 positive factors. So 2 is a prime number, 2 square will have 2 plus 1 positive factors. Into 5 is also a prime number, 5 square will also have 2 plus 1 positive factors. Total 3 into 3, we say 9. So 100 has 9 positive factors. For example, if he is asking number of factors, then also you can employ this concept. But then what you will do is you will double this value. 9 twos, we will say 18 total number of factors. Next one. N is an integer greater than 0. He is asking us to compare number of prime factors of 2n into 2n plus 2 with the number of prime factors of n into n plus 1. Now take this 2 common. If you take 2 common, 2 into 2 into n plus 1. Yeah, both will be equal. 2 square into n plus 1. Quantity A is 2 square into n plus 1. Quantity B is n into n plus 1. Now only difference between these quantities is we multiply 2 square to quantity B, we get quantity A. Now because of multiplying 2 square, are we inducing, are we bringing any new prime factors? No. Now also carefully observe, he is not asking us to compare number of factors. He is asking us to compare number of prime factors. Now n into n plus 1 is divisible. Product of two consecutive integers is divisible by 2. So in n into n plus 1, in prime factors list, 2 is already included. So here we are multiplying 2 square. Because of multiplying 2 square, all we are doing is we are increasing the power of 2 present in n into n plus 1. We are not bringing any new prime factor. So both the quantities will have same number of prime factors. N into n plus 1 will have 2 and some other numbers as prime factors depending on the value of n. Now 2 square into n into n plus 1 means already 2 is included, because if you are multiplying 2 square again, it will not like you will add or adding any other new prime factor. Already 2 is included. So no new other prime factor comes, it will also have same list. So both will have the same prime factors. You can also take example. For example, consider n is 3. If n is 3, then quantity b n into n plus 1, 3 into 3 plus 1, 3 into 4, 3 into 2 square. We say 2 and 3 are prime factors. Now what is quantity a? 2 square into n into n plus 1. It is 2 square into 3 into 4. 3 plus 1, 4 is 2 square. So all we are doing by multiplying 2 square is we are increasing the power of 2. 2 square into 2 square, it will become 2 power 4. But no new prime factor is coming. This also has 2 comma 3 as prime factors. So both 2n into 2n plus 2 and n into n plus 1 will have same number of prime factors. Both quantities are equal. We will select C, that both are equal. Next, 2a plus b and a by b are even. 2a plus b is even number. A by b is also even number. A and b are integers, then which of the following must be true? So we just need to use these concepts. Even plus even, odd plus odd is even. Whereas if you add even number with odd number or odd number with even number, resultant value will be odd. Those kind of general basic concepts. Now a is an integer. 2 into some integer will be even. To this even number, if you add even, resultant value will be even. If you add odd, resultant value will be odd. And according to him, the resultant value must be even. So b must also be even. So from the given information that b 2a plus b is even, what we are finding is b is an even number. Now a is even into b, which is also even number into any number even. A is even, b is even, a plus b. Sum of two even numbers is even, a minus b. Difference of two even numbers is even. Next, a is a multiple of 4. He is asking which of the following must be true. Can we say a must be a multiple of 4?
Yes.
Can we say a must be a multiple of 4? This option E. Yeah, it is multiple of 2. We can also say multiple of 4. Because if you observe here, a by b
No.
is even. So we said
No.
even a is even into b. What is b? B is also even number. Product of two even numbers will definitely be a multiple of 4. This even number you can write it as 2 into some integer. Another even number you can write it as 2 into some integer. So it is 4 into some integer, which will definitely be a multiple of 4. Product of two even numbers will definitely be a multiple of 4. Because regarding A, we have some information which says it is product of two even numbers, so we can definitely say it is a multiple of 4. Whereas regarding B, we cannot say that, because all we know is B is an even number. If it is an even number, is it also a multiple of 4? That we don't know. But regarding A, we are able to select that option because A is product of even numbers. It will definitely be a multiple of 4. But with respect to B, we don't have any such kind of information. So it can be a multiple of 4 or it cannot be. All we can say is it is an even number. So A, B, C, D you can easily select. In selecting E, you have to be little careful. Next question. For an annual function, an organizer needs to select some participants which should be evenly divisible in the groups of 9, 10, and 12. What is the minimum number of participants that organizer can select? Yeah, 180. Number of participants must be evenly divisible in the groups of 9, 10, and 12 means, let's say n is the number of participants. It must be divisible by 9, it must be divisible by 10, and it must be divisible by 12. Now, divisible by 9 means we say it is a multiple of 9. So, number of participants must be a multiple of 9, 10, and 12 as well. Divisible by or multiple of same equivalent notations. It gives us the same content, like same meaning. Now, he is asking minimum number. The least number which is multiple of 9, 10, and 12 is given by LCM of 9, 10, and 12. Minimum value. The least number or the minimum value which is multiple of 9, 10, and 12 is nothing but LCM of 9, 10, and 12. So this 9 can be written as 3 square, 10 can be written as 2 into 5, 12 can be written as 4 into 3. Now to find this least common multiple, take the prime number involved and raise it to the highest power present. So I've already asked, I think I might have asked when I said I'll be picking numbers, I might have asked you to go through these basic ideas like LCM and GCF and all. So if anyone is having any doubts, like watch YouTube videos regarding how to find LCM and GCF. We already discussed that. But if you are having any confusions, watch those YouTube videos. Because these are basic ideas. When you are perfect in these basic concepts, then only we can look at applications of this. So finding remainder, GCF, LCM, factors, in those basic ideas, you should not have any difficulties. So as the participants must be evenly divisible in the groups of 9, 10, and 12, I am saying that number of participants must be a multiple of 9, 10, and 12. And he is asking us the minimum value. The minimum value which is multiple of 9, 10, and 12 is given by LCM of 9, 10, and 12. Least common multiple of 9, 10, and 12. Find out what it is, we get it as 180. Next one. Digit P is the thousandth digit of A is equal to 7.24P6. Which of the following could be the value of P if A when rounded to hundredth digit has the hundredth digit equal to 4? So we are rounding off to hundredth digit. Yeah, ABC. Whenever you are rounding off to a place, just observe the digit next right to it. We are rounding off to hundredths place, so only observe the digit next right to it, what is in thousandths place. If this digit is less than 5, we write it as it is. If this digit is 5 or more than 5, we add 1 to the place we are rounding off. So according to him, when rounded off to hundredths digit, it is 7.24. Means we are writing it as it is. You would write it as it is when this P is less than 5. According to the options, we select 2, 3, 4. A, B, and C. So direct application of that rounding off concept. Next one. A is a two-digit number and B is formed by interchanging the sum of interchanging the digits of A. Which of the following could be true? If A is a two-digit number and B is formed by interchanging the digits of A, sum of A and B must be a multiple of 11 and difference of A and B must be a multiple of 9. This we have seen in that formula sheet. So select those options which satisfies this criteria. In the first case, A plus B is 63. Sum should be a multiple of 11. 63 is not a multiple of 11. Difference should be a multiple of 9. 33 is not a multiple of 9. Whereas when you take option C, A plus B is 132. 132 is a multiple of 11. And moreover, it is in our range, less than or equal to 198. So we select C. So like I said earlier, for example, if you look at this question, if you just remember this concept that it must be a multiple of 11 and difference must be a multiple of 9, it's a 10-second answer. All you will do is look at the options and select those ones which satisfies this criteria. So that's why Keep revising these concepts in the formula sheet so that you stay in touch with them, remember them, and employ in this kind of models. So these kind of questions we cannot afford missing them at all. So these are some model questions on the concepts which we have discussed it so far. If there's any doubt, let me. Next, let us discuss a small concept. N is a positive integer. So here, when I say n, I'm considering only positive integers, list of positive integers. N is a positive integer, and let's say n is divisible by 2. If n is divisible by 2, we say n by 2 must give us an integer. If y is divisible by x, first step is taking that y by x must give us an integer. Y is a multiple of x, or y is a factor of x. So y is a multiple of x, or y is divisible by x, or x is factor of y. Then we say y is divisible by x. So if n is divisible by 2, then n by 2 must give us an integer. Then what is the minimum possible value of n? A simple question. N is divisible by 2. What is the minimum possible value of n? 2. Minimum possible value is 2. Now this is a simple case. First positive multiple of 2 is 2. But generally the idea through which we get these answers is, for example, left hand side observe there is 2 in the denominator. Right hand side what do you have? Integers. Positive integers means 1, 2, 3, 4, 5, 6 like that. Do these integers have anything in the denominator? No, it's like by 1. So left hand side will be equal to right hand side only when this 2 in the denominator gets cancelled. Only when 2 in the denominator gets cancelled, then only left hand side will be equal to right hand side. You will get an integer. And how can we cancel this 2? From the numerator, only if it is present in the numerator. So n should have at least 1 2 in it. Then 2 by 2, 2, 2 gets cancelled, 1 resultant value is integer. Now let's say n square is divisible by 4. N is a positive integer and n square is divisible by 4. Now what is the minimum value of n? N is a positive integer and n square is divisible by 4. What is the minimum possible value of n? 2 again. So here you can simply say 1 square not divisible, next to 2 square is divisible. But generally, if you look at the questions given in our class exercise, m cube is divisible by 48, m square is divisible by 8 and 18. So when we come across those higher numbers, how to deal with those questions is, first expand numerator, n square, n into n. 4, 4 means 2 square, 2 into 2. Now left hand side will be equal to right hand side only when these two 2's in the denominator gets cancelled. Left hand side we have something in the denominator. It will be equal to integer only when this denominator gets completely wiped out. So we have to cancel two 2's present in the denominator. To cancel them, n must have at least 1 2 in it. 1 2 is required. Then n square, n into n, 2 square. If n has 1 2, n square will have 2 2's, 2 square. 2 2's got cancelled. Work is done. We say minimum value is 2. Now let's say n square is divisible by 8. N is a positive integer and n square is divisible by 8. Now what is the minimum possible value of n? N square is divisible by 8. 4. And also in this case, you can also say 1 square, 2 square, 3 square not divisible, next 4 square divisible. But pay attention to the process because here it's a simple case of small numbers. You can also reason it like that. But when we come across bigger numbers, we cannot keep substituting the options and see whether they are satisfying the condition or not. It would be calculationally lengthy. First, expand numerator n square means n into n. Expand denominator 8 means 2 into 2 into 2. Now left hand side will be equal to right hand side only when these 3 2's in the denominator gets cancelled. And how can we cancel those 2's? only if it is present in the numerator. So to cancel these 2's, first n should have at least 1 2 in it. 1 2 is definitely required. Then n square means n into n. N square will have 2 2's, 2 square. 2 2's got cancelled. But still there is one more 2 left in the denominator. For left hand side to be equal to integer, this 2 in the denominator must also get cancelled. How can we cancel it? N should have one more 2 in it. Then n square will have two more 2's, 2 2's. Because if n has two 2's, n square, 2 square whole power 2 will have 4 2's. We can cancel this 3 2's. What is remaining value? 2, which is integer only. So values left out in numerator, it doesn't matter for us. So in those models, in the next questions which you're going to solve in those models, look at that minimum value in such a way that you completely wipe out this denominator. The denominator gets completely cancelled so that our condition will be satisfied. So try these next questions from 7 to 9. We will discuss them in 5 minutes. Once go through these questions from 7 to 9. Concentrate here now. Let's discuss these questions. The first case is said m is a positive integer and m cube is divisible by 48. Then what is the minimum possible value of m? M cube is divisible by 48. Yeah, 12. M cube is divisible by 48 means m cube by 48 must give us an integer. So first step, expand numerator. M cube means m into m into m by 48. 48 can be written as 16 threes. 2 power 4 into 3. The resultant value must be integer. Then only we say m cube is divisible by 48. Now we have to look at the minimum value of m in such a way that this condition is satisfied. Now left hand side will be equal to right hand side only when these 4 2's and a 3 present in the denominator gets cancelled. So we have to look at this minimum value in such a way that this denominator is completely wiped out. First we have to cancel 2's. So m should have at least 1 2 in it. 1 2 is definitely required. Then if m has 1 2, m cube means 2 cube will have 3 2's. This m will have 1 2, another m, another 2, another m, another 2. 3 2's got cancelled. But there are 4 2's in the denominator. There is still one more 2 left in the denominator to cancel. To cancel that, m should have one more 2 in it. Because 1 2 is not enough, then m cube will have only 3 2's, but there are 4 2's. There is one more 2 left. To cancel that, m should have one more 2 in it. Then m cube means m cube will have 3 more 2's. Because if m has 2 2's, 2 square, m cube, 2 square whole cube will have 6 2's. So now we can cancel 4 2's. 2's are completely cancelled. Now we have to cancel 3. To cancel 3, first m should have at least 1 3 in it. Then m cube will have 3 3's. 3 3 cancel. Now what is the resultant value? 36, which is integer. So for satisfying the given condition, m should have at least 2 2's and a 3 in it. So 2 into 2 into 3, 4 3's, we say minimum possible value of m is 4. Same like the previous model, there we dealt with some simpler values. Here he has just given some larger number. Next question is also of the same order. M square is divisible by both 8 and 18. M square is divisible by 8 means you will take m square by 8 must give us an integer. M square is divisible by 18 as well, so m square by 18 must also give us an integer. So we can also proceed by dealing with these two different equations and then selecting those values of m which satisfies both. But we discussed one idea in the formula sheet. If a number is divisible by x and divisible by y, it must be divisible by LCM of x and y. So these are the kind of questions where we have to employ that. So take LCM of 8 and 18. 8 is 2 cube, 18 is 9 to 3 square into. Now LCM, least common multiple. To find this least common multiple, take the prime number involved and raise it to the highest power present. 2 cube into 3 square. This is LCM of 8 and 18, 72. So m square must be divisible by 72. So m square by 72 must give us an integer. That means m square. Expand this numerator m into m. Expand the denominator 72 means 8 9s. 2 cube into 3 square must give us an integer. Now we have to look at this minimum value in such a way that this condition is satisfied. So first you have to cancel 3 2's in the denominator. To cancel these 2's, first m should have at least 1 2 in it. 1 2 is definitely required. Then m square will have 2 square, 2 2's, 2 2's, 2 2's get cancelled. But there are 3 2's in the denominator, so still one more 2 is left. To cancel that, m should have one more 2 in it. Then m square will have 2 more 2's. If m has 2 2's, m square will have 4 2's, 3 2's, 3 2's done. Now there are two 3's present in the denominator. We have to cancel them as well. To cancel these 3's, m should have 3 in it. So let's say m has a 3 in it. Then m square, m into m will have 2 3's, 3 into 2 3's got cancelled. What is the resultant value? 2, which is integer. So for satisfying the condition, m should have at least two twos and a three in it. So we said what? Minimum possible value of m is 12. So if there's any doubt or any confusion in this approach, let me know. In the next case, he's asking which of the following will divide each and every integer m, every integer m. Now this 12 is the minimum value. Other possible values are multiples of 12 because 2 into 2 into 3, 4 into 3, 12 is definitely required. Into some other integer, it doesn't matter. 12 into 1, 12 into 2, 12 into 3, 12 into 4, like that. 12 must be there. 2 into 2 into 3 must be there. Extra, if you multiply some other integer, no problem. This 12 is the minimum value. Other possible values are multiples of 12. He is asking which of the following will divide every integer m. So if it divides 12, it will definitely divide multiples of 12. So select those options which are dividing 12. 4 will divide 12, 6 will divide 12, 12 will divide 12. Whereas 84, 8 and 24, 8 and 24 will not divide 12. So we select 4, 6 and 12, the numbers which divides 12. Next question. If P, Q and R are integers, if P, Q and R are integers and Q is a multiple of P and R is a factor of P, which of the following is not necessarily an integer? He is asking which of the following is not necessarily an integer. Not necessarily an integer means out of the five options, four will definitely be integer. One will not be or cannot be. You have to find out what it is. So first, whenever you see these terminologies, first step is taking y by x gives us integer form. Y is divisible by x, or y is multiple of x, or x is a factor of y. Then we take y by x gives us an integer. Q is a multiple of p. Q is a multiple of p means q when divided by p, resultant value is integer. R is a factor of p. R is a factor of p, so p when divided by r must also give us integer. Just I'm differentiating, let's say I1, I2. So using these as reference, whatever description he has given, we are representing it mathematically. Using these references and using the ideas that when we add two integers or subtract two integers or multiply two integers, we will get integer. Using those ideas, we have to comment on those, like we have to evaluate those options and find out which is not necessarily an integer. First one, q minus p by p. It is q by p minus 1. Q is a multiple of p, so q by p is an integer minus 1. Difference of two integers is definitely an integer. Next one, q minus p by r. It is q by r minus p by r. R is a factor of p, so we know that p by r is an integer. So q by r. Now one way is without going through any other evaluations, directly using the reasoning that q is a multiple of p means q is divisible by p. If q is divisible by p, it will also be divisible by factors of p. So it will be divisible by r also. Or else take this to q by p into multiply with p by r. Q by p is an integer, p by r is an integer, product of two integers is some other integer. P get cancelled, c by get q by r. Q by r is an integer, p by r is an integer, difference of two integers, integer. Whereas if you take option C, it says q minus r by p, q minus r by p, which is q by p minus r by p. Now q by p we know it is an integer, r by p, r is a factor of p, so p by r is an integer, r by p means reciprocal of this. Now we don't know whether it is integer or not, because if I2 value is 1, 1 by 1 you can say integer. If it is 2 or 3 or 4, some other value like that, we say it's a fraction. So this is not necessarily an integer, q minus r by p. We select C. And if you evaluate D and D, there you will get that they are integers only. QP square by R, which is Q into P by R, all are integers. Product of three integers, integer, or Q by B plus R. Q by P is an integer plus R is an integer. Sum of two integers, integer. So we'll select C here, which is not necessarily an integer. So before break, let us discuss a small idea just for 2 minutes. For example, let's say there is a number n if it is divisible by 5. Let's say n is divisible by 5. If I say n is divisible by 5, we take that n by 5 will give us an integer. We already solved some problems on that just now. Now let's say n when divided by 5 leaves a remainder 2. N when divided by 5 leaves a remainder 2. Values of n satisfying this condition will be of the form 5 into some integer plus 2. 5 into some integer plus 2. The values of n which satisfies this condition. This is based on dividend. Dividend is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. Dividend is the number which we divide. Divisor is the number with which we divide. And quotient, I am denoting it with some integer. Now different values will give us different quotients. So you substitute different values for I, you will get different values of n satisfying this condition. For example, let's say we are considering only positive integers. 5 into 0 plus 2, 2. 5 into 1 plus 2, 7. 5 into 2 plus 2, 12. Like that, keep adding 5, 17, 22, like that. These are the list of numbers which will leave a remainder 2 when divided by 5. Plus reminder means the required remainder. In this example, I said remainder is 2, so plus R plus 2. So just like when you see y is a multiple of x or x is a factor of y, these terminologies, you take it as y by x gives us an integer. Now in the next questions, when you see the word remainder, first step is take it in the form of dividend is equal to divisor into quotient plus remainder. That first step would be common. And after that, based on what he is asking and what he has given, our next steps will depend. So this is another model present in this number systems based on this reminder. So try the next questions from 10, 11 and 12. 10, 11, 12. As well as take a break for 15 minutes and try these three questions. I'll resume the class in a 20 minutes. So class resumes in 20 minutes, after which I will discuss these three questions. So please be back in.
के भएन n is divided by 60 advantage in here
Concentrate here now. Let's discuss these questions. N is a positive integer which leaves a remainder 9 when divided by 60. Which of the following cannot divide n? So I said n when divided by 60 leaves a remainder 9. N when divided by 60 leaves a remainder 9. So take it in the form of dividend is equal to divisor into quotient plus remainder. Let's see how the values of n will be there. Like the ones which leave a remainder 9 when divided by 60. N will be of the form 60 into some integer plus 9. N will be of the form 60 into some integer plus 9. So any number of the form 60 into some integer plus 9, it will be an odd number because 60 is an even number. Even number into any integer it is even, plus 9 is odd. Even plus odd resultant value will be odd. Even plus odd resultant value will be odd. So n is an odd integer. So 6 and 12 cannot divide odd number. Look at any number divisible by 6 or 12, they are all even numbers. Because if a number is divisible by 6, it must be divisible by factors of 6. Means it must be divisible by 2 also. Similarly, if a number is divisible by 12, it must be divisible by factors of 12. It must be divisible by 2 also. So any number which is divisible by 6 or 12 must be divisible by 2. And if a number is divisible by 2, we say it is even. So 6 and 12 cannot divide odd numbers. And if you look at this 60i plus 9, any number of the form 60 into some integer plus 9 will be definitely a multiple of 3. 60 is a multiple of 3, 9 is also a multiple of 3. Sum of two multiples of 3 will be a multiple of. Whereas to comment on 9, let us look at how the values of n will be there. You give different values per integer, we will get different values of n satisfying this. 60 into 0 plus 9, which is 9. 60 into 1 plus 9, 69, 129, 189, like that. If it is 9, 9 will divide 9. If it is 189, 9 will divide 189. 9, 189, 369, like that. Some of the possible values for n are divisible by 9, whereas some are not. So we don't know what is the exact value of n. All we can say is it is in the form of 60 into some integer plus 9. And if you take these integers in the form of 60 into some integer plus 9, some are divisible by 9, some are not. So we say 3 will definitely divide, 9 can divide. 9 can divide some of the numbers possible for n, whereas 6 and 12 cannot. So first step is we are taking like how the values of n are coming out to be. N will be of the form 60 into some integer plus 9. And any number of the form 60 into some integer plus 9, we say it is an odd number. So 6 and 12 cannot divide odd numbers. Then if you look at the possible values of n, 3 will definitely divide all these numbers, whereas 9 can divide. 9 is dividing some of the possible numbers. So we'll select only 6 and 12. Next, m and n are positive integers which leaves a remainder of 3 and 2 respectively when divided by 6. Then which of the following can be the remainder when m plus n is divided by 12? He said m when divided by 6 leaves a remainder 3. N when divided by 6 leaves a remainder 2. He is asking what is the remainder when m plus n is divided by 12. What about here? What would be the remainder when m plus n is divided by 12? When m plus n is divided by 12, what would be the remainder? What? No one in the class answered this question. M when divided by 6 leaves a remainder 3, and when divided by 6 leaves a remainder 2. We need remainder when m plus n is divided by 12. Is it only 5? Is 5 the only possibility? See, m when divided by 6 leaves a remainder 3 means m will be of the form 6 into some integer plus 3. Yeah, 5 and 11. N when divided by 6 leaves a remainder 2 means n will be of the form 6 into some integer plus 2. And differentiating them is important. Because if you are getting answer as 5, that means you are using same here, I and I. When we add, you are saying 6i plus I, which is 12i, 12 into some integer plus 5. That's wrong. That's conceptually wrong. Because what is this I here? Some representation which we are using to denote integers. If you are using same letter for m, 6 into I plus 3 and same letter here, that means if I substitute 1 here, I should substitute 1 there. If I substitute 2 here, I should substitute 2 there. Is there any necessity that we should give same integers in both the cases? No. I can give whatever integer I want here for m in the case of 6i1 plus 3, and I can give whatever integer I want there. So differentiation is also important. Observe this. So these are just some letters which we are using to represent And in the same question, when we are dealing with different situations, you have to use different representations. I1, I2, two different integers. Or they can be same also. They can be taking same values, different values, any values you can give. Now m plus n. 6 into I1 plus I2 plus 3 plus 2, which is 5. What is I1 plus I2? I1 is some integer, I2 is some integer, sum of two integers, some other integer. 6 into some integer plus 5. If he is asking reminder with respect to 6, you would have directly compared with the form and say 5, but he is asking with respect to 12. So find out what are the values of m plus n. One way to answer this is find out what are the values of m plus n. 6 into 0 plus 5, 5. 6 into 1 plus 5, 11. Keep adding 6. 17, 23, 29, like that. These are the possible values. 5 when divided by 12, remainder is 5. 11 when divided by 12, remainder is 11. 17 when divided by 12, remainder is again 5. 23 divided by 12, remainder is again 11. So 5, 11, 5, 11, like that. This is how reminders comes out. So the possible values of remainder here are 5 and 11. So I said m when divided by 6 leaves a remainder 3, and when divided by 6 leaves a remainder 2. First, we are taking it in this form. Dividend is equal to divisor into quotient plus remainder. And one important thing which you have to remember is giving different representations. Let's say I1, I2. Then m plus n. Find out what is m plus n. It is in the form of 6 into some integer plus 5. Then look at what are possible values, and those values when divided by 12, they are giving remainder as either 5 or 11. Two possible values. Next one. N when divided by 3 leaves a remainder 1, and when divided by 4 leaves a remainder 2. What is the remainder when n is divided by 12? So this is another model present in this topic. He said n when divided by 3 leaves a remainder 1, n when divided by 4 leaves a remainder 2. Now there are two conditions given to us which we need to satisfy. Here we have to find those values of n which will leave a remainder 1 when divided by 3, and which will leave a remainder 2 when divided by 4. Two different conditions to satisfy. So how to deal with these questions is first go to each case individually and find out what values of n are satisfying these conditions. N when divided by 3 leaves a remainder 1. So values of n will be of the form 3 into some integer plus 1. N when divided by 4 leaves a remainder 2. So values of n satisfying this will be of the form 4 into some integer plus 2. Let's say I1, I2. Now find out what are the values which leaves a remainder 1 when divided by 3. If integer is 0, 3 into 0 plus 1, 1. Then keep adding 3, 4, 7, 10, 13, 16, like that. Similarly, n when divided by 4 leaves a remainder 2. Values of n satisfying this 4 into 0 plus 2, 2. Then keep adding 4, 6, 10, 14, 18, like that. Now our value n must satisfy both these conditions. Satisfying both the conditions, values of n will be of the form LCM of numbers involved, LCM of 3 and 4, LCM of 3 and 4 into some integer plus first common term. LCM of 3 and 4 into some integer plus first common term. So LCM of 3 and 4 is 12 into some integer. First common term means first term which is common to both the sequences. 1 not present, 4 not present, 7 not present, 10 present. 10 is the first term which is common to both the sequences. So values of n satisfying these conditions will be of the form 12 into some integer plus 10. Now what he is asking remainder with respect to 12. So no need to find out values of n and observe. Directly compare it with this form. Dividend is equal to divisor into quotient plus remainder. We are dividing with 12 and the corresponding remainder is 10. So first we talked about n is divisible by 5. N by 5 gives us an integer. N when divided by 5 leaves a remainder 2. N is 5 into some integer plus 2. And in this case, we are talking about values of n which satisfies two different conditions. Satisfying both the conditions, n will be of the form LCM of numbers involved into some integer plus first common term. The first term common to both the sequences. So these are some other model problems on this concept of remainder. If there's any doubt, let me. So now let us discuss some other remaining concepts. Go to this formula sheet. I think page 157 or 156. We have discussed up to 34. Try the remaining from 35 to 40. 35 to 40 from formula sheet. We will discuss them in 5 minutes.
गोली में ये ला रहे हैं क्यों तो कपड़ा को शॉप से था तो दूसरा ना जाओ ना तो शॉप कपड़ा है तो लगा यहाँ कौन ना तुम एकदम अलग बस मॉर्निंग ना इसलिए एकदम राम्रो युज छ तो कपड़ा लाग्यो होला नि के वर्ष छोडेर
Monsoon ready है ना?
Hmm?
35th we have already discussed. What is the relationship between dividend
मेरै होला
divisor,
कहिले त्यस्तो
quotient
भन्दा
and remainder?
म किनेसी
Dividend
लगाइदिइहाल्छु
is
कस्तो
equal to divisor into quotient plus
मतलब
remainder.
गर्नु
Just now we have solved problems.
कलेज भयो
Now
के
let
हो
us look
जिवेस
at divisibility test
कलेज
of the
ड्रेस हो
required
दे
numbers here.
ए
A number is said to be divisible by 2 if the last digit is divisible by 2. A number is said to be divisible by 2 if last digit is divisible by 2. And a number is said to be divisible by 4 if the last two digits are divisible by 4. A number is said to be divisible by 8 if last three digits are divisible by 8. A number is said to be divisible by 8 if last three digits are divisible by 8. For 2, last digit must be divisible by 2. For 4, last two digits must be divisible by 4. For 8, last three digits must be divisible by 8. For 3, sum of digits must be divisible by 3. Sum of digits must be divisible by 3. For 9, sum of digits must be divisible by 9. For 5, last digit must be 5 or 0. For 10, last digit is 0. For 10, last digit is 0. For 2, last digit must be divisible by 2. For 4, last two digits are divisible by 4. For 8, last three digits must be divisible by 8. For 3, sum of digits is divisible by 3. For 9, sum is divisible by 9. For 5, last digit must be 5 or 0. And for 10, last digit must be 0. So these are the divisibility test of numbers which you must be aware of. Next one. From 1 to 50, there are 15 prime numbers. And from 1 to 100, there are 25 prime numbers. From 1 to 50, there are 15 prime numbers. See, those are divisibility tests. What I should repeat in that? Tell me. Take a screenshot and read them. It's not a concept to repeat. That's what I'm saying. 36. What I should explain in this? What is your doubt here? See, take a screenshot and read it. I can't explain this. What is there to explain? Tell me now. Let me know. This is the test, divisibility test. How to check a number is divisible or not. A number is said to be divisible by 2. Even if I say I will be reading what I wrote on this slide. A number is said to be divisible by 5 if last digit is 5 or 0. If last digit 5 or 0, 15,
बुढो बिर्से
20, 25. If last digit is
यत्रो
5
चाहिँ
or
राम्रो
0,
भयो होइन
we
लास्टमा
say
फेरि
number will be
क्यान
divisible by
रिपिट अल अफ
5.
इट अरे
These are tests which you have to read and learn and
एउटा
remember,
फुट्यो होला नि त्यसको
not
चाहिँ
concepts to explain.
सधैँ होला
And a number is said to be divisible by 10 if last digit is 0. 10, 100, 20, 30. Take any number divisible by 10. Last digit will be 0. A number is said to be divisible by 3 if sum of digits is divisible by 3. A number is said to be divisible by 3 if sum of digits is divisible by 3. For example, take 96. What is sum of digits? Sum of digits means here what are digits? 6 is one digit, 9 is another digit. Add this 9 plus 6. You will get 15. Is 15 divisible by 3? Yes, it is. So we say 96 is also divisible by 3. A number is said to be divisible by 3 if sum of digits is divisible by 3. A number is said to be divisible by 9 if sum of digits is divisible by 9. Sum of divisible. For example, take 999. 9 plus 9, 18 plus 9, 27. This is sum of digits. 27 is divisible by 3. So we say 999 is also divisible by
Kuburan la was
9.
niya.
27 is divisible by 9. So we say 999 is also divisible by 9.
College la
And a
niya.
number is said to be divisible by 2 if last digit is divisible by 2. For example, 12, 24, 36. Take these last digits. If it is divisible by 2, or in other words, if
Class
it is
hoya
even,
hai.
we say that number will be divisible by 2. For 4, last two digits must be divisible by 4. For example, take 164. Last two digits 64. They are divisible by 4. So we say 164 is also divisible by 4. For
Wait
8,
man.
last three digits
क्या
must be
continue
divisible
बोले
by
यार.
8. If last three digits are divisible by 8,
हाँ?
then we say number is divisible by 8.
हाँ.
For example, take
वो
8, 8,
मजाले
8,
बुझाइ
8.
सकेको थिएँ किन
Last
सोधेको
three digits, take this last three digits.
त्यो
8,
जोकले
8, 8,
एकचोटि
8.
हाम्रो
It
बसेको
is
थिएँ
divisible by 8.
क्या.
So we say this total number is also divisible by 8. Just read them and learn them. What are these divisible teachers?
अघि नै भेट्दै नभेटेको लास्ट टाइम फलमा सिट भन्ने रहेछ त के भएन अब एउटा आउँछ तर त्यो सिम्पल पनि थियो.
Next, 1 to 50. 1 to 50, there are 15 prime numbers, and from 1 to 100, there are 25 prime numbers. And this is also, there is nothing to explain it. A number is said to be prime if it has only two positive factors, one and the number itself. You have to find prime numbers 2, 3, 5, 7, 11,
नै
13,
आउँछ
17, like that. You have to find and count them.
कसले
If you count them from 1 to 50, you will get 15 prime numbers, and from 1 to 100, you will get 25 prime numbers. So there isn't any formula to calculate this. You just need to remember these values. That from 1 to 50, there are 15 prime numbers, and from 1 to 100, there are 25 prime numbers. And also after this, take any interval of 100. Take any interval of 100, number of prime numbers will be less than 25. 100 to 200 less than 25. 200 to 300 less than 25. 300 to 400 less than 25. So in some concepts, like one of the question we are going to look in class exercise, there he is asking how many prime numbers are there from 1 to 1000. Now no need to remember all these values. Just knowing these two are enough. So for example, if you don't know this value, he is asking 1 to 1000. Now then we cannot keep finding out what are prime numbers from 1 to 1000 and then count them. Even the total time of exam wouldn't be sufficient. So if you remember that from 1 to 100 there are 25 prime numbers, and 100 to 2, from after that take any interval of 100, number of prime numbers are less than 25. Using this directly we can answer those questions. So like I said, in number systems we'll come across some models where if you remember these ideas, then it would be one or two step answers, direct option selections. So from 1 to 50 there are 15 prime numbers, and from 1 to 100 there are 25 prime numbers. And after that take any interval of 100, number of prime numbers will be less than 25. No need to know that value, just knowing that less than 25 is enough. Next one, concept of cyclicity. Let us look at the power cycles of these numbers. This concept of cyclicity, power cycles of numbers, talks about whenever a number is raised to any positive integer, what will it end in? A number, whenever a number is raised to any positive integer, what will it end in? End in the sense, what will be its units digit? What will be units digit? We need to find out. So units digits, when different numbers are raised to some higher powers, that we get from this concept.
9:30 आधी घन्टासम्म.
For example, let's say 2 is in the units digit of a number. That number, when raised to any positive integer, will end in either 2 or 4 or 8 or 6. 2, when raised to any positive integer, will end in either 2 or 4 or 8 or 6. For example, 2 square 4, 2 cube 8, 2 power 4 16, 16 ends in 6. And after that, 32, 64, 128, 256. Again this 2, 4, 8, 6. After that 512, 1024, 2048, 4096. Again 2486. This cycle continues 2486, 2486 like that. So 2 when raised to any positive integer will end in the sense I'm talking about units digit will either be 2 or 4 or 8 or 6. 2486, again 2486, again 2486. After that again if you take 8192, 16384, 32768, 64536 like that, if you keep going on, it will this cycle continues 2486, 2486, 2486 like that. So using these
मलाई
power cycles of numbers, whenever a number is
यहाँ
raised
पाउँदैन
to any positive integer, you will find out what will be the units digit. For example, let's say you need to know what is units digit of 12 power 50. For example, let's say we need to find out what is units digit of 12 power 50. Now whether it is 12, 152, 252, 552, what is the number, it doesn't matter. As long as 2 is in the units digit, the final units digit will depend on this 2 only. It doesn't depend on the complete number. It only depends on the units digit of that number. So consider only units digit. Units digit of 12. Units digit of 12 is 2. So 2 power 50. Now you have to find out what will be the units digit of 2 power 50. For finding that, what you will do is take this power. What is power? 50. Find out what is remainder when divided by 4. Find out what is remainder when divided by 4. 50 when divided by 4, remainder is 2. 50 when divided by 4, remainder is 2. So we say second number in the power cycle. And also, why am I dividing with 4? Because it continues in the cycle of 2486. After that, remainder is 2 means one cycle done. Next, for example, if you take 6, 6 when divided by 4, remainder is 2. One cycle is done 4 terms. Again 2, 4, we say second term. Remainder is 2, so second term 2, 4. If it is a multiple of 4, you say fourth term 6. 2, 4, 8, 6. 4, 2 power 4 will end in 6. Again 2 power 8 will end in 6 like that. So as it continues in the cycle of 4, find out remainder when divided by 4. Here power is 50. 50 when divided by 4 leaves a remainder 2. So we say second number in the power cycle. If remainder is 1, we say first number in the power cycle. Remainder is 1, first number in the power cycle. If remainder is 2, second number in the power cycle. If remainder is 3, third number in the power cycle. And if remainder is 0, fourth number in this power cycle. So we will solve some problems in class exercise through which you can get much more acquainted related to this model. Now let us see power cycles of these numbers. 3 when raised to any power will end in 3 or 9 or 7 or 1. 3. Next 3 square 9. 27 ends in 7. Next 81 ends in 1. After that again 243 ends in 3. 729 ends in 9. Next 2187 ends in 7. After that whatever number comes it will end in 1 again. So this cycle continues 3971, 3971, 3971 like that. For 4 it is 46. But for these numbers as we are looking in terms of 4, let's say 4646. So 4 power 1 4. 4 square 16. 16 is ending in 6. Then 64 ends in 4. Then 256 again 6. Then 1024 4. Then 4096 again 6. Then after that 16384 again 4. 65536 again 6 like that. This 4646 this cycle continues. For 7, for 7 it is 7931. 7 when raised to any positive integer will end in either 7 or 9 or 3 or 1. These are the possibilities 7931. And also, what I would suggest is remember this power cycle because if you remember directly, you can write it down. But even if you forget, for example, let's say you need the power cycle of 7. First, take 7. 7 into 7. 7 into 7, 49 will end in 9. Now after that, if you need the next one, no need to multiply entire number. No need to multiply 49 into 7 and say 343. Whenever you are finding units digit at every step, consider the units digit of those respective numbers only. 7 into 7, 49. 49 is ending in 9. Then 9 into 7. 9 into 7 is 63. 63 will end in 3. Then 3 into 7. 3 into 7 is 21. 21 will end in 1. Because if you forget again 49, 49, 7 you multiply 343. Again 343 into 7 you keep multiplying. Then it will be taking time. No need to multiply the entire number. Just multiply those units digits. 9 into 7, 63 and will end in 3. 3 into 7, 21 will end in 1. Similarly, for 8 power cycle is 8426. 8 when raised to any positive integer will end in either 8 or 4 or 2 or 6. Similarly, for 9 power cycle is 91. But like I said, for these numbers as we are looking in a set of 4, let's say 9191. These are the power cycles of these numbers using which you will find out what will be the units digit when different numbers are raised to some positive integers. And if you look at the numbers missing from this list, 0156. 0156 when raised to any positive integer will end in themselves. 0156 when raised to any positive integer will end in themselves. For example, 0 is in the units digit. When that number is raised to any positive integer, it will end in 0 only. For example, consider 10, 10 square 100, next 1000, 10,000, 1 lakh, 10 lakhs like that, they end in 0. Similarly, if 1 is in the units digit, for example, consider 11, 11 square, 121 ends in 1. Then 11 cube, 1331 ends in 1. And after that, some other number you get, that also ends in 1. Similarly, for 5, 5 square, 25 ends in 5. Next, 125 ends in 5. 625, 3125, 15625, like that. If we keep taking those numbers, they will end in 5. Similar for 6 as well. 6, next 36, next 216, next 1296. All these are ending in 6 only. So if it is 0156, it would be easy for us. You will directly say they will end in themselves. But if it is some number from this list 2, 3, 4, 7, 8, 9, you have to use the power cycles of these numbers to find out when those numbers are raised to positive integers, what will they end? Like earlier, we took some example with 12 like that. So this is about the power cycles of these numbers and this one set of circuits. And also answer for the 38, which digits raised to any positive integer will end in themselves. 0156 when raised to any positive integer will end in themselves. So if there's any confusion here, let me know. Next one. Squares of integers never end in. Squares of integers never end in. That means if you're taking square of a number, a perfect square number, what will not be the units digit of a perfect square number? Now consider any number, take any number, its units digit will be one of this from 0 to 9. 0 to 9 it would be one of this digit. Now if you take the square of a number, units digit of the square of a number will depend on what is the units digit of that particular number. So whenever you are taking squares, if 0 is in the units digit, 0 square will end in 0. 1 square ends in 1. 2 square ends in 4. 3 square ends in 9. 4 square ends in 6. 5 square ends in 5. 6 square 6. Again 9, 4, 1. So these are the possible numbers from 0 to 9. When you are taking the squares, they are ending on 0 or 1 or 4 or 5 or 6 or 9. And what are the numbers missing from this list? 2, 3, 7, 8. So squares of an integer, square of an integer will never end in 2, 3, 7. If it is a perfect square number, its units digit will not be 2 or 3 or 7 or 8. Any of these four numbers will not be present in the units digit. Square of an integer will never end in 2, 3, 7. So these are some model problems. Some, these are some other concepts present in this topic. In addition to what we have seen, the LCM, GCF, factors, multiples, in addition to those questions. Here, squares of integers never ending, or power cycles of those numbers, or 1 to 100 there are 25 prime numbers from 1 to 50, 15 prime numbers, divisibility test. So in all these cases, you have to read them, remember them, memorize. Like 1 to 100, 25 prime numbers are there. Because is there any concept there or formula? No, you just have to read and memorize them. Similarly, divisibility test. How do you say a number is divisible by a particular number? For example, let's say he is giving some bigger number like 1, 2, 4, 5, 6, 7, 8. You want to know whether it is divisible by, let's say, 4 or not. Instead of dividing the complete number and observing whether it is divisible by 4 or not, you can simply take last two digits. Your last two digits are not divisible by 4. So we say it is not divisible by 4. So for easy getting answers easily in less amount of time, and also in some other models like we are going to see in class exercise, we will be using this concept. And also, for example, let's say a number is given to us like this: 468572. Now you need to know whether it is a perfect square number or not. So when you have some 5 or 6 or 7 digit numbers, it would be very difficult for us to see whether it is square of an integer or not. To get answers easily, the concepts which we use in mathematics or Vedic maths, that's are completely out of our this general academical maths and everything. Those are different areas. So even the total time of this section wouldn't be sufficient here to know whether it is perfect square number or not. If you have to generally go checking by squares of some numbers because it's a 6 digit number. But if you remember this concept, that square of an integer will never end in 2378. All we have to do is look at this units digit. Its units digit is 2. If it is square of an integer, its units digit will not be 2. So here units digit is 2. So we can directly say this is not a perfect square number. This is not square of an integer. So for example, let's say he's asking which of the following is not square of an integer. Let's say it is a multiple choice question with single answer. He will give in such a way that only one of the option will have either 2 or 3 or 7 or 8 in the units place. You just have to look at that option and select. So keep revising this concept so that you stay in touch with these kind of ideas. You do not forget them and employ in these kind of direct questions. So now let us solve some problems. Go to this class exercise. Class exercise of numbers and try solving questions 13, 14, 15, as well as 16 and 17. Concentrate here now. Let's discuss these questions. Part 2 can hold us to complete the project if the dash represents the dash digit which has been omitted. Which of the following could be the number of hours that he took to complete the project? So one complete day or one whole day will have 24 hours. If it is n days, n complete days will have n into 24, 24 into n hours. One day will have 24 hours. 2 days means you will say 24 into 2. 3 days means 24 into 3. 5 days means 24 into 5 like that. N complete days will have 24 into n hours. So number of hours, whichever option represents number of hours, it must be of the form 24 into some n, which is nothing but a multiple of 24, or we say divisible by 24. And any number which is divisible by 24 must be divisible by factors of 24. So number of hours must be divisible by 1, 2, 3, 4, 6, all these numbers, factors of 24. Now use the divisibility test of those numbers which we have seen to find out what option could represent this number of hours. Now divisibility test of 2 is not useful here because all the given numbers are even. In all the cases, last digit is divisible by 2. And a divisibility test of 3. We cannot use the divisibility test of 3 because numbers are like this 6 dash 36. A number is said to be divisible by 3 if sum of digits is divisible by 3. Sum of digits is divisible by 3. Here one digit is omitted. When one digit is omitted, how can we find the sum of digits? Now when we cannot find the sum of digits, we cannot use the divisibility test of 3. Out of 4 digits, only 3 digits are given. So divisibility test of 3 is also of not use. Now use the divisibility test of 4. A number is said to be divisible by 4 if last two digits are divisible by 4. If last two digits are divisible by 4, then we say number is divisible by 4. And look at those options except in option B. Except in option B 6 dash 36. In no other option, all the numbers are divisible by this divisible by 4. 98, 850, 90, 62, they are not divisible by 4. If they are not divisible by 4, they will not be divisible by 24. If they are not divisible by 24, they cannot represent the number of hours. So only B could represent the number of hours. A, C, D, E cannot. So first idea is number of hours will be of the form 24 into some integer. And any number of the form 24 into some integer, we say it is a multiple of 24 or divisible by 24. If a number is divisible by 24, it must be divisible by factors of 24 also. It must be divisible by 4. But when you look at the options, only option B is divisible by 4, others are not. So we say B, we'll select B here. Next, number of prime numbers from 1 to 1000, you have to compare with the 300. What quantity would be greater here? Number of prime numbers from 1 to 1000, you have to compare it with 300. Which quantity would be greater? Yeah, quantity B. So the concept which we have seen is from 1 to 100 there are 25 prime numbers. 1 to 100 there are 25 prime numbers. After that, take any interval of 100, number of prime numbers are less than 25. But just assume that they are 25. Even if it is 25, like 100 to 200, 200 to 300, like that, in any each and every interval, even if it is 25, from 1 to 1000, there are 10 intervals of 100. 1 to 100, 100 to 200, like that, 10 intervals are there. So value will be 10 into 25. But they are not 25, they are less than 25. So value would be something less than 250. Whereas quantity B is 300, so we say B is. So these are the kind of problems which we should not miss at all. Just remember these ideas and we will directly get the answer. That from 1 to 100 there are 25 prime numbers. After that, take an interval of 100, number of prime numbers will be less than 20. Next one, it's the model on finding the unit digit. You have to find out what is units digit of 233 power 22, 727 power 23 into 929 power. So finding units digit is the same process in any kind of the number given to us. So look at the step-by-step approach, how we are finding this units digit. First, only consider units digit of these numbers. 233, 533, whatever it is doesn't matter. Only consider units digits. 3 power 22, 7 power 23, 9 power. Now use the power cycle of these numbers to find out what will they end in. Power cycle of 3 is 3971. 3 when raised to any power will end in either 3 or 9 or 7 or 1. Four possibilities. Now out of these four numbers, which number it is you need to find out. Further take this power. What is the power? 22. 22 when divided by 4, remainder is a 2. 22 when divided by 4, remainder is 2. So we say second number in the power cycle. Second number in the power cycle, which is 9. 7 power 23. 7 power, I think I wrote this power. Yeah, I hope you know the question and looking at these questions and looking at this table. Yeah, yeah, I got it. 3 power 23 into 7 power 22. So power here is 23. 3971, 23 when divided by 4, remainder is 3. Remainder is 3 means third number in the power cycle. Then 7 power 22. Power cycle of 7 is 7931. 7 when raised to any positive integer, it will end in either 7 or 9 or 3 or 1. Now you have to find out which one it is. For that, take this power 22 by 4, remainder is 2. Remainder is 2 means second number in the power cycle. Then for 9, power cycle is 9191, third number 9. And also here, when we get a product like this, no need to find out what is the exact value like 9 nines 81, 81 7s 567, like that. No need to find the complete number and then see what is the unit digit. Like here, what we did, we are not considering total number, we are only considering unit digits. Similarly, at every step, consider only unit digit of that particular calculation. Take this 9 into 9. 9 into 9 is 81. 9 square will end in 1. 1 into 7. 1 into 7 will end in 7. Just to consider units digits. So first I'm taking units digit of those numbers. We get it as 3 power 23, 7 power 22, 9 power. Now using the power cycle of these numbers, you have to find out what will be the units digit. For 23, for 3 power is 23. 23 divided by 4, remainder is 3. So we say third number in the power cycle, it will end in 7. Similarly, for 7 power 22, it is coming out to be 9. For 9 cube, it is 9. Then 7 into 9 into 9. Instead of multiplying, I am further taking 2 at a time and further simplifying it, only considering units digit. 9 into 9, 81 will end in 1. Then 1 into 7 will end in 7. Final units digit is 7, whereas quantity B is 1. We say A is great. So finding units digit, you must be very comfortable with. Then we can look at some other conceptual problems. N is a positive integer. Remainder when 2 power n divided by 10. You have to compare with remainder when 7 power n divided by 10. So remember this point. This is also one of the important idea present in number systems. Whenever you have to find out remainder when dividing with 10 or 5, whenever you are dividing with 10 or 5, if you want to find remainder, remainder will depend on what is in units digit. If you know units digit, you can get that remainder. For example, consider this 19 by 10, remainder is 9. or 159 by 10, also remainder is 9, or 189 by 10, also remainder is 9. In all the cases, units digit is 9, remainder is 9. So whenever you are dividing with 10, whatever digit is present in the units place, that will be our remainder. Whereas when you divide with 5, if it is some number from 0 to 4, it will be remainder. If it is some number from 5 to 9, you have to subtract 5. For example, 14 by 5, remainder is 4. Or 154 by 5, remainder is 4. Or 244 by 5, remainder is 4 only. As long as 4 is in the units digit, when divided by 5, you will get remainder as 4 only. But if it is some digit from 5 to 9, subtract 5. For example, 18 by 5. 18 by 5, what is remainder? 8 minus 5, you will say 3. Or 288 by 5, what is remainder? If 8 is in the units digit, remainder will be 3 only. So whenever you have to find out what is remainder, when you are dividing with 5 or 10, just to find out what is in units digit. If you know what is the number present in the units digit, from that we can arrive at this remainder. So look at this problem. 2 power n. Now based on n, we give different values, accordingly units digits will come. For power cycle of 2 is 2486. These are the possible units digits. As it varies 2486 here, accordingly for 7 it varies 7931. So just check for first four numbers in the power cycle. Based on that, other numbers again it will follow the same trend. So we just need to get units digits. So if n is 1, 2 power 1 by 10, 2 by 10, we say remainder is 2. Here 7 by 5, remainder is 2. Both are equal. If n is equal to 2, 2 square 4 by 10, remainder is 4. And 7 square 49. Or second number in the power cycle 9. 9 by 5. Because whenever you are dividing with 5, you should only know units digit to find the remainder. That is enough. No need to take the exact number. Remainder is 4. But if when n is 3, 2 cube 8 by 10, remainder is 8. Whereas here 7, 9, 3, 1, third number 3, 3 by 5, remainder is 3. In this case, quantity A is good. When n is equal to 1 or 2, we are getting both are equal. But when n is equal to 3, we get that quantity A is greater. Right? N is equal to 1 or 2 equal, n is equal to 3, quantity A is greater. So dual relations, we will select option B. That relationship cannot be. And also, like when you keep solving problems, we must employ different techniques so that we get answers in less amount of time. Just looking for n is equal to 1 is enough. When you look for n is equal to 1, we get reminders are equal. Immediately you can reason that, okay, n is equal to 1, I got reminders are equal. But if I give n as 3, 2 cube is 8. 8 by 10, we get remainder as 8. But when divided by 5, can we have a remainder 8? When you are dividing with 5, remainder can be something from 0 to 4 only. 2 cube is 8. 8 by 10, you get remainder as 8, which definitely makes quantity A greater there. But n is equal to 1, both are equal to different relations only. So when dividing with 5 or 10, remainder will depend on what is present in the units digit. Next, last one for today's class. Which of the following could be the units digit of 37 power x into 21 power x plus 1 into 35 power x plus 2? So what he is asking us? Units digit. As he is asking us units digit, only consider the units digit of these numbers. 37 power x, it is 7 power x into 1 power x plus 1 into 5 power x plus 7 power x into 1 power x plus 1 into 5 power x plus 2. Now find out what will be units digit of this product. 0156 when raised to any positive integer will end in themselves. 0156 when raised to any positive integer will end in themselves. So 1 power anything will end in 1. 5 power anything will end in 5. Into 7 power x. 1 into 5 will end in 5. Now we don't know what is the value of x, but 7 when raised to any positive integer will end in either 7 or 9 or 3 or 1. 7 when raised to any positive integer will either end in 7 or 9 or 3 or 1. Now when you multiply with 5, 7 into 5, 35 will end in 5. 9 into 5, 45 will end in 5. 3 into 5, 15 will end in 5. 1 into 5, 5 will end in 5. Any odd number multiplied by 5 will end in 5 only. So irrespective of the value of x, we get this units digit as 5. So whatever value of x, it doesn't matter, because 7 power x, there are only 4 possibilities, either 7 or 9 or 3 or 1. But any of this number when multiplied by 5 is ending in 5. So we just select 5 here. So these are some model problems on this power cycles of those numbers and some other general ideas which we have seen. So in this formula sheet, page 157 or 158, look around there. Try the remaining concepts present in this formula numbers, which we will continue in our next class. We have discussed up to 40. So 41 to 45 or 44, whatever present in number systems. Go through those concepts. And after that, in our next class, we will discuss these remaining concepts in number systems and problems. And after that, we will start statistics. Stats. In stats, we have different concepts, mainly mean, median, mode, range, weighted arithmetic mean, standard deviation, normal distribution, box plot. These are the concepts present. So regarding each and every term, you just have basics. What is mean, how to calculate mean. What is median, how to calculate median. Only those basics are required. So once look at the definition of these terms and come prepared to the class. So this is it for today. We'll meet again in our next class on a Friday and we will discuss these concepts. Thanks for your time.